Okay, so as x approaches negative infinity, y approaches what? Negative infinity. Okay. Okay, so let's look at it really quickly. What do I mean? Okay, as x is approaching negative infinity, what direction am I going? To the right or to the left? To the left. Where's y going? To the down. To the down. Okay, as x is going this way, y is going here. That's why we say y approaches negative infinity. So on this line, we write negative infinity, okay? So we know yesterday, we said the degree is 3, the x-intercept's 3, the number turning point 2. Brooke? This is a verbal representation of that, right? So as x approaches what? Okay, which way am I going? Okay, what's happening to y as I keep taking a step to the left? That's right. So if x is going to be approaching like negative 1,000, where would y be? Somewhere really, really low. That's what this right here means. This whole symbol right here, x arrow negative infinity, and then y arrow negative infinity, this whole thing right here is the verbal representation of that. Do you guys agree? Okay. That's why we're spelling it out because it's so new to us, okay? Next, limit notation. The limit as x approaches what? Negative infinity of this function, whatever this function is. In this case, we're dealing with a cubic function. What should that equal to? Negative infinity. So guys, this answer, that answer, and that answer, these three things are asking exactly the same. It's just different representation of the same question. Are we clear? Okay. Next, x arrow infinity. Y arrow what? Infinity. Also infinity. So verbal representation of that is, what do we write?
As x approaches infinity, y approaches infinity.
Thank you. Okay, now limit notation. Here we go. Limit as x approaches infinity of our function, which is a cubic, equals, what should I make it equal to? Infinity. Okay. So that's the end of our cubic. Now I want you to go and graph out our next function. Where do we go to even enter in our graph? Go to y equals. I want you to talk to your partner. Like, oh man, I forgot. What did you do yesterday? Okay. What button do you press to put in fourth power? The caret, the hat. Okay. If you did cubic already, someone else did the fourth, and then someone else did the fifth. Okay. Yeah.
No, I literally haven't pressed anything.
No, that's store. Yeah, remember that yesterday? Yeah. Guys, if you have questions, ask me now. Okay, enter it in. You were asking yesterday, ask one another. Oh no, what can you do? You were asking yesterday, ask one another, please. That looks awesome. Guys, if you were asking yesterday, I need you to talk to your friend. Did you enter that or did she enter that? He entered it. Okay, graph. Once you have the equations, what do you press?
Oh shit. Sure.
Oh, I forgot. Don't go on. Don't go on. Okay. Entering the quartic. Here, I have to start over. Yeah. What power? Yeah, and then Dylan, talk to your team, okay? Do you have sort of like a W looking shape? Good. Second graph. All right. The question is asked, now that I have a W-looking shape, what do I press? What do we press at the table? Second graph. Everyone get second graph with me because I'm going to call you to give me the values. Ready? Okay, so everyone has a W-looking shape. So now I will be calling all of us to give me a couple values. Not all of them will be used, but that's okay. All right, the calculator. Here we go. Gabe, when x is -3, what did the calculator say? Second graph. -3. Y is?
152.
152. Thank you. Dylan, when x is -2, hon, what did the calculator say for y?
32.
32. Nope. Read it. Find it. What do we press, Dylan? I know, but do you have a table on your calculator? Okay, get there. It's not the matter of an answer. It's I'm trying to help him out. Everyone, tell him what to press to get the table. Can you verify now? Good. Guys, it's never really the answer. It's about the process. Okay. Emma H. When x is -1, what's y?
-2.
-2. When x is 0, Joe. X is 0.
When x is 0, it's -4.
When x is 1, Chance.
-4.
When x is 2, Emma P.
X is 2.
Mm-hmm.
-8.
When x is 3, Hannah. Okay. Is that enough to plot?
Yes.
I'm obviously not going to plot -3 or -2, but I will start -1, okay? So -1, x is -2. Is that right? So far, so good? 0 is -4. 1 is -4. 2 is -8. 3 is +2. Okay, so on the right side, looks like I have enough to give me my first. Does it look something like this? Someone confirm that for me?
Yeah.
Okay, so based on the calculator, it looks something like that. Yes or no?
Yes.
Yeah, all right, let's answer the rest on the bottom. Okay. At -2, you can go all the way to 32. At -3, you can go all the way to 152, but I don't have enough room for that. Degree. Kennedy, what's the degree for this function? Good. Look at the equation, okay? Ms. Amanda, how many x-intercept do you see?
2.
Perfect. Now, cautiously, Gemma, how many turning points? 3. Okay, now this is difficult to see because they're so close to one another. Let me just stretch it out. Gemma said 3 with a question mark. Is that one turning point right there?
Yes.
Yes. They are close to one another, but that's actually a second. It's frozen, so I'm just waiting for it to unfreeze.
Have you tried restarting that?
Oh no, sometimes like if I make it too fat, don't think fast enough, and then it just. Okay, anyway, as it's thinking. So Gemma said 3, so this is 1, this is 2, and then this is the third one. So Gemma is correct. Okay, so 3. We are not going to verbally spell it out anymore, but here we go. This arrow represents what word? Approaches. As x approaches -infinity. Y approaches what? Positive infinity, right? So positive. Then limit notation. Limit as x approaches -infinity of our quartic function, which is just f of x for now, equals. What is it equal to? Infinity. All right. Then this right here, x, read it to me. Yeah, x approaches infinity. Y approaches infinity. Okay. All right. So limit notation. Limit as x approaches positive infinity of our quartic equation. It also equals to infinity. Guys, follow along, please.
As x approaches positive infinity. Am I supposed to be answering that?
Yeah, sounds good.
Y approaches positive.
Good. Okay, follow along. I didn't even ask you, but thank you. All right, erase your quartic equation and punch in quintic equation, please. How do I clear up a previous equation? Just press clear. Yep. All right, press clear. And then you and your partner, I want you to answer all of the following. Actually, you know what? Just graph it. Don't answer anything. Wait. What does it look like?
It's like a squiggle.
I know, the table is so funky.
Why is there so many zeros?
I know. That doesn't make sense.
It really doesn't.
What does the graph look like?
The graph doesn't look like that.
Does the graph look like going up and down?
Yeah.
Oh. Is the table broken?
Yes.
Okay.
Oh, is it because it's like bigger?
For now, to make things simple, the limits will exist. Okay. All right. Now, the comment is the table is just too weird. Right? There's a lot of zeros. You guys see it? But we can change that. The reason there's a lot of zeros, can you see there are curves up and down, but they're the really low curves, like they're closer to zero? Okay. Here's how we're going to change the table. Can you do me a favor? Find the button that says window. Do not press it, please. Do not press it. Just find it. It's okay. Just hit graph. Okay, just locate it. Don't press it. Are we good? I want you to hit second window. Second window. Hit second window. Can you see there's a new screen? It says table set up. Okay. Table set up. Can you see it?
Yes.
Can you go to the line where it says triangle and then TBL, table? In math or in chemistry or in physics, what does a triangle mean? Huh? Delta, right? Delta means what? Change. Okay, we're about to change the table. Right now, there's a number 1. That's a normal setup. I want to change it to like 0.5. Hit 0.5. And then go and hit second table again. Table. Second table. No, second. Well, second graph. Whatever. Table. Second table. No. What do you see?
A
lot more numbers. But now, did you see there's higher y values and low y values in between? Okay. Now, I'm going to ask you for a lot of them. Okay. But that doesn't mean I'm going to use all of them. So here we go. I'm going to start with like -3, -2.5, -2, -1.5, -1, -0.5, 0, 0.5, 1, 1.5, 2, 2.5, and 3. Right, just to have a variation, but that doesn't mean I'm going to plot all of them. So Hope, based on your calculator, when x is -3, what did the calculator give you? -120. Someone confirm that for me, since I don't have a... Yeah. Lena, when x is -2.5, the calculator says what? 29.63. 53, thank you. 29.53. James, when x is -2, the calculator says what?
0.
When x is -1, Carly?
-1?
I'm sorry, -1.5. I lied.
3.2813.
3.28. Is that okay? 2 decimal places. We'll keep it simple. How about Brooke? -1.
0.
-0.5. Arista. We'll come back to Rissa for negative 0.5. How about Hunter at 0?
0.
Thank you. 0.5, Anthony.
1.4.
Someone confirm? Confirm. Brandon C. When x is 1, what did the calculator say?
0.
When x is 1.5, Roger?
Negative 3.28.
Thank you. When x is 2, Daniel? When x is 2.5, Aaron?
29.63.
Thank you. And last one, McKenna? I can't hear you.
120.
120, thank you. All right, so Rissa, negative 0.5, what did you get, hon?
Negative
406, okay. All right. I'm obviously not going to graph negative 29 or positive 29, okay? So I'm going to start with negative 2, 0. Is that okay? But the reason I want it there so I know how to go or what direction to go towards 2. Negative 1.5 is now positive 3.28. 1, 2, 3. So it's pretty close to one another. 2, 3. So somewhere in the middle is fine. Negative 1 is back at 0. You're going to have a lot of x-intercepts here. Negative 0.5 is now negative 1.4 below. 0 is back at 0. Positive 5. Positive 0.5, I'm sorry, is 1 point. Oops, this needs to go beyond 1. This one right there. Then 1 is back at 0. That's another x-intercept. 1.5 is negative. 1.5 is negative 1, 2, and 3. Negative 3 and some change right there. 2 is back at 0. And 2.5 is like shooting back up. Okay, so I'm not going to go all the way to 29, but that allows me to know that it shoots back up. And this side knows it shoots back down. Okay, so that's sort of what I'm looking for. Okay. There's a lot of x-intercepts. There's a lot of real zeros. Okay, so now let's answer the other parts of the question, okay? Delaney, what's our degree today?
5.
What's our degree today, hon? What's the highest x power? 5, okay? The highest exponent of this is 5. Now look at it carefully. Kai, how many x-intercepts do we see? 5. Okay. X-intercept is when it touches or crosses what? X-axis. Okay. Now count carefully. How many? Madison R, how many turning points do you see? 4. So let's see. 1's right there. 2, 3, and 4. Yep. You are right. 4. Okay. Then, here we go. Verbally, we're not going to spell it out anymore, but we should be able to read this from now on. If I give you this, it says what? As x approaches negative infinity, y approaches also negative infinity. Okay. Limit notation. Limit as x approaches negative infinity of our f of x, which is this one, quintic, y approaches negative infinity. Now, read this for me. Hannah, read this for me. That highlighted one on the bottom.
Okay. When x approaches positive infinity, y approaches.
Good. Limit notation. Here we go. Limit as x approaches positive infinity, like Hannah said, it should equal to infinity. Okay. Now, look at the y's. Can you see like the y is approaching? Are the y's approaching opposite directions or the same direction? Look at the y's. Are they opposite direction? Yes or no? One is going negative and one's going positive. How about on the fourth power? Look at the y's for me. Are the y's going the same way or opposite ways? They're both going what? Up. Okay, look at the third power for me. Is the third power opposite or the same? All right. Now, huh?
Oh, when it's R, they go different ways from the team and they go the same.
Whoa! That's what I want you to write right there. What are some patterns? That's one of them. When the degree is odd, how are the y's going?
Opposite.
Perfect. Okay? Alright. So Hannah said odd degrees. Odd degrees. Okay? Any odd degrees. 3, 5, 7, 9. Okay? Y approaches same direction or opposite direction? Opposite. Y approaches opposite directions. Okay, when they are odd. How about when we have an even degree?
Same direction.
Thank you. Okay, Y approaches, whoops, can you help me? Okay, same direction. They can both go down, they can both go up, but they have to be the same. Okay, what other do you see our pattern based on all 6 of these graphs? What else? Let's talk about turning points. Let's start with the degree of 5. How many turning points do you have? 4. Degree of 4, how many turning points? Degree of 3, how many turning points? So what's the pattern? Okay. So the turning point is 1 less. Okay. The turning point is 1 less. But it's not always, it doesn't have to be 1 less. It's just going to be, I can have, remember, the turning point is going to be, does it have to be exactly, let's say they have a degree of 5. Right now, for this example, has a turning point of 4. Does it have to be up to 4? No, it could be 3, 2, 1. It just has to be up to 1 less than the degree, okay? So turning points. Turning points is up to, not exactly, no, it just have to be up to. Up to what? 1 less than the degree, okay? 1 less than the degree. We're spelling it out. Okay. How about the x-intercepts? If you were given a degree of 5, how many x-intercepts do we have? This one degree is 4. How many x-intercepts? This one degree of 3. X-intercept? So what's the pattern? It's usually the same. So what we say is x-intercept is no more than the degree, okay? Up to, or no more than the degree. So x-intercepts, bless you. By the way, guys, x-intercept is the same as real roots or real solutions, okay? They are used the same way. X-intercept, real roots, it's no more than what? Than the degree. Or up to, okay? Perfect. So those are the pattern. That's why we did so many, so you can come up with the pattern. All right, here we go. I'll do the first one with you. The first one, can you guys assume that this touches the x-axis for the sake of simplicity? Can you see those all touches? If it doesn't touch on your paper, just make them touch, okay? All right, bless you. We're going to answer it vertically down, okay? Number 1, what is the end behavior? On the first one, we're going to verbally spell it out, but we won't do it on the next 2. This one really say what? As x approaches, y approaches. Okay, go ahead and write out infinity and then verbally spell this out. And then this is probably our last time spelling it out. As x approaches negative infinity, y approaches infinity. Okay. Limit notation, limit as x approaches negative infinity. It didn't give you an equation, but that doesn't matter. I can still use f of x, okay? F of x, and then that equals infinity. On the bottom, verbally, what do we say for this thing? Yep. No, you got it right. As x approaches. Yes. So as x approaches infinity, y approaches infinity. Okay, so that's the last time we're going to verbally spell that out. Gabe? Yes, sir. Okay, so limit notation is, okay, there you go. Next question. How many real zeros does it have? This question is the same as what? We've answered this many times already on the first 6 graphs.
Oh, degrees.
Not degree. How many real zeros?
X-intercept.
X-intercept. Real zero is the same as the x-intercept. Now look at the graph. How many x-intercept do you have?
3.
So how many real zeros is that?
2.
3.
If you have 3 x-intercept, you will have 3 real zeros. Okay? Now, look at the turning points. How many?
3.
Okay? 1 is at the bottom, 1's on the top, and 1's at 0. So 3 total. Now, last question. Look at the y. Is it going the same way or opposite way?
Same way.
So it can only be what kind of degree? Even or odd?
Even.
Even.
2,
Okay.
4.
It can be 2, 4, 6, 8.
2.
Now you have to look at the stuff.
4.
4. Ah. Remember, the turning point is 1 less than the degree. So remember, I can have, so this is a possible 4. It can be 6. It can be 8. But can it be 5? No, it has to be even because the y's are going the same way. All right.
If I wrote 8, it'd be right.
Yeah, for sure. Oh, yeah. All right, why don't you do this one? You and your partner. Do B for me. Go. No, we are not pretending such a. This does not touch at all. Okay? This one does not touch the x-axis at all. I gave you an extra page. Remember I said like, do that page 8? That was funky. It wasn't page 8. Because remember I stapled it wrong and I said make sure you staple not. Yeah, I gave you two separately because I copied it wrong. Tonight's homework is a review. It's not anything we're learning right now. We're not done with the notes yet, so I'm not giving you any homework. Am I going to go over this homework tomorrow? Yeah. No. Where can you find the right answer? Online. So your stuff, come and see cover tutorial. Everything except today's lecture. Everything in Unit 2B except today's lecture. All right, here we go. We're no longer verbally spelling this out. Are you ready? Grace, can you help me read this right there, the highlighted piece? X approaches. Beautiful. Okay, Grace said when x approaches negative infinity, y is also approaching negative infinity. Yes, no, maybe? Yeah, all right, here we go. Limit. Limit as x approaches negative infinity of this function. We don't know what it is. It never gave us an equation. It just gave us a graph, but it's still a function. Y approaching negative infinity. All right, next, can you help me read? Okay. This green highlighted piece. Okay, Victoria. Yes. So let's look at the y. Is the y approaching the same way or opposite ways? So what kind of even can it be? Odd or even? Oh, I just asked to give you. What kind of even? What kind of degree can it be? Even degrees only, okay? So limit notation. Limit as x approaches positive infinity of our given graph. Y is approaching negative. How many real zero does it have, Baron? That's right. None. Yes or no? Did it ever cross the x-axis? No. How many turning points, Brandon N, does it have? Brandon N said 3. Do you guys agree with Brandon? Yeah. Sydney, what could be a possible degree? 4. Can I write 6? Can I write 8,000? Yeah, sure. As long as it's even. Okay, as long as it's not less than the number of turning points.
For limit notation, you have to put the x and the arrow below it. You just say like f of x equals negative 50.
Where are you, hon?
Limit notation. Can you just say f of x equals negative infinity instead of writing?
No, this whole thing has to be exactly like that. Exactly like that. All right, last one. You try. I'll come back in a minute to ask you. Give me the questions. Go ahead, start.
Did you find it?
No, I was just copying it.
I think I have extras. No one wanted it. Yeah, it looks like this. Remember this? I give you a separate.
Yeah. Thank you.
So you might want to save them together.
Okay, so you and your partner do the last one. Look at the notes, guys. Look at the notes. Your partner too? All right, Madeline L., can you tell me the first one in this green right here? What did you write?
As x approaches negative infinity, y approaches infinity.
Beautiful. I like that. Limit notation. Limit as x, arrow, negative infinity of our function. Y equals infinity. Okay, so next one. McKenna, can you help me read this yellow highlighted piece right here? Beautiful. Okay, class, are the y values approaching the same way or different ways? Same or different ways? Different. So what are the possible degrees? Odd or even? Odd. Okay. Limit notation. Limit as x approaches positive infinity of our current function. This one says negative infinity over here. Next. How many real zero do you guys see? 2? Okay. So 1 is right here and 1's right here. How many turning points do you guys see? Also 2. Okay. What is a possible degree for this function? 3. Guys, it cannot be less than the turning point. It can be 3, 5, 7, 9, 101. Okay. So that's how we identify it. Now, let's do everything else by hand. You guys ready? Okay, go to the next page. Heck yeah.